In the last video, you learned about planning research. In this video, you will learn about supporting the research process around building background knowledge, collecting data, analysis and interpretation, and academic products. Helping your students learn the background information necessary to be able to conduct research can come from different avenues. The better foundation you create at the beginning of the research process supports your students in becoming more independent and confident by the end of the program. You can help the students activate prior knowledge through brainstorming, listing, bridging concepts, asking focused questions, and providing real-world examples. Another method is by providing learning objectives. Be really helpful, especially when the mentee is learning new concepts or skills. Using structured learning and inductive teaching can help keep students from feeling overwhelmed by lots of new concepts in a short period of time. This is sometimes called just-in-time teaching, and help students access the information they will need just in time to use it. It can be really helpful to use a diversity of sources, such as websites, blogs, journal articles, podcasts, textbooks, expert input from other researchers and students, and videos. Be sure to encourage active learning and inquiry by your mentee. Help them find opportunities to learn skills from peers in the lab and to seek out more information about your research topic. The Mentoring Handbook has a section of sample questions that spur the learning process and can be found on pages 24 and 25. Please refer to those for questions that are useful for any stage of the research process. After discussion of your research program, student and mentor goals, and anticipated skills gained, develop a research question that can be addressed in about 6 weeks. Start by making observations of data and/or phenomenon first. Use brainstorming techniques to develop a research question with the mentee. Along with your mentee, think about what is necessary for answering the research question. When developing the research questions that the student will be addressing, mentors should encourage students to think about research ethics. This is a really important time to model addressing ethical concerns regarding the research. Does the student need IACUC training if they're working with animals? If they will be studying humans, do they need CITI training? It's also a good idea to have the students take the Responsible Conduct of Research training from the Research and Innovation Office. The students will likely not know what types of additional training is necessary, so it's important for the research mentor to make these requirements known to the student and help them gain access to the training materials. Collecting, storing, and cleaning data are important considerations for research programs. Helping students learn how to do these steps in responsible and ethical ways is foundational for their training. For the first few rounds of learning something new, work with your students side by side if possible. This helps with troubleshooting issues and dispelling any misconceptions, and this will save time down the road. Have students write out step-by-step protocol or methods for the tasks they'll be performing. This also allows them to teach somebody else, which will reinforce their learning. Help your student understand the kind of information being collected: physical specimens, continuous or categorical data, observations, or more. Are there ethical considerations for collecting and storing of this data? Help the mentee understand the organizational frameworks for specimens, files, and data used in your lab. Explain to them why metadata is important, or README files. Learning new software or programming language takes time. Practice patience and remember what it was like when you were first learning coding. This can take a lot of the student's time. Check back with learning goals set by you and the mentee to make sure this is in alignment with those goals. Please be prepared to provide extra support. Data analysis with your research mentee. Discuss who will be responsible for the data analysis. Will the student be helped by you or another researcher to analyze the data? Will they be working with a subset of data they collect or a larger data set collected by somebody else? There are ways you can help the student to reflect on their learning that will support the analysis of data. You can ask clarifying questions, ask open-ended questions, or ask insightful questions that tap into their creative thought. What methods will be used for the analysis? What does previous literature say about this? Does your analysis make sense? These are all reflective questions that will support the student in becoming better researchers. Here we'll think about interpreting results with your research mentee. Some questions to ask your mentee to help them interpret their findings include: what are the most important results from your study, and why do they matter for understanding your research question? How do your findings compare to existing research? And in what ways do they support, extend, or challenge what is already known? What unexpected results did you encounter? And what are some possible explanations for why they occurred? What are the key limitations of your study? And how might they have influenced your results or interpretations? Based on your findings, what questions remain? and what future research would be most valuable to pursue. What is the most important takeaway from your study, and why should others care about it? When preparing academic products with your research mentee, remember the early stages of cognitive domain. Start writing early with the development of the introduction or informal science communication, like a blog post. Writing a protocol for tasks the student will be performing can form the basis for the method section and give them the opportunity to teach another researcher their process, which further taps into the cognitive domain. The student should be able to describe the process of analysis. Encourage your student to create data visualizations. Support the students through discussing the research findings, using students' prior knowledge and what was learned through the process. What conclusions can be drawn from the findings? Help them to critically reflect on the process. Remember the questions in the handbook on pages 24 and 25. Encourage your students to practice their presentations within the lab group and to integrate feedback from the lab group or their peers. Now, how can you support your student through research setbacks? A great first step is to model intellectual humility. Share with your students times when your research didn't work out and how you dealt with that experience. Normalize not knowing things and asking questions. Encourage critical reflection about what went differently than expected. This allows for updating protocols and iterating, which are important parts of the research process. This process of refinement ultimately helps to answer research questions. What was learned from making mistakes? Do the protocols need to be changed or updated? Does the research question need reframing? If you need support in providing mentoring for your students, there are several resources available. You can find these resources through your professional organizations, the book, Entering Mentoring, which is a free resource online, and through the university. In this module, you learned about how to scaffold the research experience for your mentees. Join us in the next module to learn about inclusive mentoring.